Hi, boys and girls. Welcome to Grade 4, Module 5, Fractions, Lesson 12. In today's lesson, you will be able to use benchmark fractions to compare two fractions on a number line. For today's video lesson, you're going to need your dry erase sleeve, a dry erase marker, and your eraser. If you prefer, you're welcome to use your math notebook. As I work out problems in this video, you are expected to do them too on your dry erase sleeve. You may pause the video if I'm going too fast. Okay, let's start with a warm-up. We are going to draw number lines with tape diagrams. The directions say draw and label a tape diagram to model 2/3. So let's break up our tape diagram into thirds, and then we're going to model that by shading 1/3, 2/3. So let's think about our number line in the same way. We are going to line up the end of our tape diagram here is 0, and over on this end it represents 1, because on our tape diagram from here to here equals 1. So we showed the same distance equals 1 on our number line. Then to break it up, I can do a line here and a line here. And again, these lines are in the same places as they are on my tape diagram. So it's the same idea, except when we're dealing with a tape diagram, it's a rectangle, but when we're dealing with a number line, it's just a single line. So it's different thinking about it, but we still have 1, 2, 3 pieces. 1, 2, 3 pieces. Okay. So now let's label our number line. I would label this as 1/3 and this as 2/3. On my tape diagram, to show that something is 2/3, I would shade 2/3 of my drawing. But on a number line, to show something represents 2/3, I can mark it by putting a dot or a point on my number line. Okay, now it's your turn to practice. Please draw a number line and plot 1/4 on your number line. Press play when you're done. Okay, to plot 1/4 on a number line, I'm going to start by labeling my 1 hole. Put my 0 and my 1. Now to break into fourths, I'm going to first cut my number line in half. And then I'm going to cut each of those halves in half. So I have 1/4, 2/4, 3/4, and 4/4. To plot 1/4 on a number line, I can mark it with a dot or a point. All right, I would like you to plot 1/3 on a number line on your dry erase sleeve. Press pause on the video while you do this and press play when you're ready to check your answer. Okay, this is what your number line should look like. You've labeled your endpoints as 0 and 1 hole. You've divided it into 3 equal segments, and you've put a point on 1/3. Make sure everything's labeled and you have your point on your number line. All right, now I'd like you to try plotting 2 numbers on just one number line. So you're going to draw one single number line, and you're going to try and plot 1/2 and 5/6 on that number line. Pause the video and press play when you're ready to check your work. Okay, so I started by labeling my endpoints 0 and 1 hole because neither of my fractions are bigger than 1 hole. Now I'm going to start by plotting 1/2. Well, I can just divide my number line into 2 equal pieces and label that as 1/2. Now I need to make 5/6. I would break each half into 3 equal parts. So I have 6 total parts on my number line. 1/6, 2/6, 3/6, 4/6, 5/6. So now I'm able to plot my points on my number line. 1/2 is here and 5/6 is here. You've plotted both numbers on one number line. All right, let's take it a step further with our application problem for today. How could we plot 1/4, 4/5, and 5/8 on the same number line? I want you to think about this and try to do it on your own. Pause the video and press play when you're ready to move on. All right, let's start plotting these 3 points on one number line. As always, I'm going to label my hole. 0 to 1 whole is what my number line represents. Now I have to label 1/4. That's my first fraction. So to do fourths, I can cut my number line in half and then cut each half in half. Now I have 4 equal pieces, and I have 1/4 right here. The next one, so I've done this one. I'm going to jump over to 5/8, and I'm going to try and put that one on there because I think it's pretty easy to go from fourths to eighths. To go from fourths to eighths, all I have to do is decompose each of my fourths in half. And now I have eighth size pieces. So I can count 1, 2, 3, 4, 5, and I can label 5/8 right here. Okay, so this is where I think it gets a little tricky. Now we have to put 4/5 on our number line. And we already have fourths and eighths labeled on there. Fifths don't go easily into fourths or eighths, so this one's going to take a little bit more thinking. So I know that 1/5 is a little bit smaller than a 1/4 size piece. So I'm going to put my fifth line right here. So I'm going to have to kind of reason through because it's hard for me to divide this up with all those other dashes on there. So then I'm going to add another fifth to this. So now let's see where I can put my next one. My next one looks like the fifth would be about there. And it's a little bit less than this 1/2 mark. So maybe if I label that, that'll be helpful to think about where 1/2 is. So I think that 2/5 is a little bit smaller than 1/2. So then I'll try to make my next mark on here. I know that 3/5 is going to be bigger than a half. And that looks like it's about 1/5 away. And I'm going to add my last fifth on there and try to make it about 1/5 away. So I want to see that my pink lines are evenly spaced. And then I have 1/5, 2/5, 3/5, 4/5 would be right here. So it gets a little confusing when we start to put all of those lines on here. Later in the lesson, we'll practice just adding individual fractions without dividing the whole number line up. So, my question to you, when you're asked to compare numbers in math, what are you being asked to do? So I want you to pause the video and think about that. Hopefully, you remembered that when comparing numbers in math, you're trying to figure out which number is bigger or smaller. You can list the numbers in order from least to greatest, or another great way to compare numbers is using the less than, greater than, or equal to symbol. Let's use the number line we made to compare 1/4, 4/5, and 5/8. So when I look at my number line, I can see that 1/4 is the smallest on there. So I could say something like 1/4 is less than 5/8 based on where they are on the number line. Or I can make another statement like 5/8 is less than 4/5. Additionally, I can just list them in order from least to greatest. And I see 1/4 first, then next is 5/8, then finally is 4/5 from least to greatest. So those are a couple of ways that we can compare numbers using a number line. In today's lesson, we're going to use fraction benchmarks to help us compare fractions. In other words, we are going to use common fractions or numbers that we're really familiar with to help us figure out which fractions are bigger or smaller using less than, greater than, or equal to symbols. So a benchmark is a standard reference point. For example, when we were studying the metric system, we said that a centimeter benchmark would be our pinky finger because 1 centimeter is about the size of our pinky. So we take something that we know and apply it to a new concept. So in fractions, we use benchmarks like 0, 1/2, and 1 to help us compare fractions. So we can ask ourselves, is this fraction close to 0? Is it close to 1/2? Or we can ask ourselves, is the fraction closest to 1/2 or to 1? And that'll help us to put it on the number line without making all of those different marks, those little hash marks on the number line like we did in the application problem. Let's start by comparing fractions to the benchmark 1/2. My first question, how many sixths equal 1 whole? Think of it. How many sixths equal 1 whole? Hopefully, you know that 6 sixths equal 1 whole. Now, this next one you may need to think about for a minute. How many sixths equal 1/2? You can visualize it, you can draw a model, or you can use multiplication or division to figure out how many sixths equal 1/2. I'm going to use a multiplication sentence to figure that out. I want to know how many sixths equal 1/2. So I'm going to start with the fraction 1/2. And I'm going to say that 1/2 equals, I want to know how many sixths. So to go from halves to sixths, I need to triple my total number of units. So that will also triple my shaded number of pieces. So 1/2 equals 3 sixths. 1/2 is equivalent to 3 sixths. Okay. Is 2 sixths greater than or less than 3 sixths? So if we have 2 out of 6 pieces and we have 3 out of 6 pieces, we should know that 2 sixths is less than 3 sixths. Finally, then the question says, is 2 sixths less than 1/2 or greater than 1/2? To figure that out for sure, we can go ahead and put this on our number line. 1/2 is the same as 3 sixths. We figured that out. We also know that over here is 6 sixths from a previous question. Now I need to plot 2 sixths on my number line. To do that, I can break up my 1/2 into 3 equal pieces, because if I divided the whole thing up, I would have to break 1/2 into 3 equal pieces and my other half into 3 equal pieces. So this is 1/6, 2 sixths. I already have my 3 sixths for 1/2. And to make sure that I was right dividing my 0 to 1/2 into 3 equal pieces, I can divide my other half into 3 equal pieces, just to make sure that I'm on the right track. 1 6, 2 6, 3 6, 4 6, 5 6, 6 sixths. So on the number line, we can see that we have 2 sixths right here and 3 sixths right here. So we can see that 2 sixths is closer to 0 than 3 sixths is. So 2 sixths is less than 1/2. All right, we are going to compare fractions to the benchmark 1/2. We have 2 questions. Is 2/3 greater than 1/2 or less than 1/2? And the second question, is 2/5 greater than 1/2 or less than 1/2? Let's think back to our application problem. We plotted 3 fractions on one number line, and we had a ton of fraction marks, and it got a little bit confusing to plot. So let's try to think of this as it relates to 1/2 and not mark up the entire number line and actually measure out all of the distances. Let's start with 2/3. So I want to think of putting that on the number line. Well, when I visualize, I have 1/3 or 2/3 on my number line. So let's just look at a separate number line really quickly. If we have 0 and 1, and we break it up into thirds, we have 1/3 and 2/3. Well, when I think about 1/2, I know 1/2 is directly in the center. So 1/3 is a little bit smaller than a half. 2/3 is a little bit bigger than 1/2. Or I can think about it. This 2/3 right here is 1/3 away from 1/2. So I can think about the distance. It's actually closer to 1/2 than it is to 0. So when I'm plotting on my actual number line, I don't have to put the 1/3 on there like that. I can erase that, and I can just plot the 2/3, which I know is going to be a little bit bigger than 1/2, but not quite to 1/2. It's going to be about 1/3 away from 1/2. And this kind of reasoning is going to help my number line stay really clear and just focus on the fractions I'm dealing with, like 2/3 and 2/5. So let's come to 2/5 now. And again, I could divide my whole number line into fifths, but I want to try and keep my number line a little bit cleaner and just reason through it. So just to do a model number line here again, if we have 0 and 1, I can divide it all into fifths. So we have 1/5, 2/5, 3/5, 4/5, 5/5. But then I can start to think, if I have 1/5 here and 2/5 here, so 2/5 away from 0, and then if I come around to this other side, I have 1/5, 2/5 away from 0. So I can kind of figure out exactly where that middle point is here. So I can see through reasoning that 2/5 is going to be right here. It's going to be a little bit less than my 1/2 mark. And we'll talk a little bit more how we can kind of figure those things out a little bit better. But it's going to be a little bit less than 1/2. So I can label that as 2/5. So let's come back to our questions. Is 2/3 greater than 1/2 or less than 1/2? So if I find 2/3 on my number line right here, and I compare it to 1/2, I can see that 2/3 is greater than 1/2. My second question, is 2/5 greater than or less than 1/2? I can see 2/5 right here compared to 1/2 right here. So I can say that 2/5 is less than 1/2. Okay, we're going to continue to compare fractions, and this time we're going to use the benchmark 0, 1/2, or 1 possibly. So we're being asked to compare 5/12 to 7/8 using less than, greater than, or equal to symbols. And we have a number line below with our 3 benchmarks, 0, 1/2, and 1. We want to try and plot 5/12 and 7/8 on our number line without measuring. Something that's going to really help me do that is to think of my benchmark fractions 1/2 and 1 using the unit and the fractions above. So let's start with twelfths, for example. 1/2 is the same as 12/12. Now, let's figure out what 1/2 is using the 12ths unit. There's a bunch of strategies you can do to figure this out. 1/2 is a fraction that we can typically make more sense with, but let's make sure we can figure that out using multiplication. So we have 1/2 equals 1/2, and we know we want a unit of 12. So to go from halves to twelfths, I would have to times it by 6 because 2 times 6 is 12. So if my number of units is going up by a multiple of 6, I also need to multiply my numerator, or total number of parts, by 6. So using multiplication, I find out that 1/2 equals 6/12. So I'm going to erase that work to keep my model clear, and I'm going to label this as 6/12. Now, without putting all of my other marks on there, let's try and plot 5/12. So we know that we have 0/12, we have 6/12, and we have 12/12. Which of those benchmarks is 5/12 closest to? 0, 1/2, or 1? If you guessed 1/2, you're correct. 5/12 is just 1/12 away from 1/2. So if we put a little line there, that's probably about a 12th from here to here. It's about 1/12. It might be a little bit big, but we get the idea. We know that it's a 12th smaller than 1/2. So we can label this one as 5/12, because it would go 5/12, then 6/12, or 1/2. So without dividing my number line into 12 equal pieces, I was able to figure out where 5/12 would fit. Now it's not perfect, but it's pretty darn close. All right, next up is putting 7/8 on our number line without actually measuring. So just using what we know about 0, 1/2, and 1 to get 7/8 on our number line. So I'm going to do the same thing. I'm going to think of 1 whole as 8/8, and I'm going to think of 1/2 as 4/8. 4/8 is equivalent to 1/2. 4 is half of 8, right? So I have those two on there, and now I need to think to myself, this 7/8, where is it going to land? Is it going to land closest to 1/2 by the 4/8? Is it going to be closer to 8/8 at 1 whole? Well, I can figure out that 7/8 is just 1/8 away from 8/8. So I can put my mark on there, and I'll put it about here. I want it to be a little bit bigger than my 12ths, because 12ths is a smaller piece than my 8ths, so I made it a little bit bigger, but it's still reasonable. So I can plot this on there as 7/8. So now I have 5/12 and 7/8 plotted on my number line without actually measuring by doing every single 12th and every single 8th mark. Now I'm able to easily see that 5/12 is less than 1/2, while 7/8 is almost 1 whole. So that tells me that 7/8 is greater than 7/8 is greater than 5/12. So we would put in our symbol like this. Let's continue to compare fractions using benchmarks 0, 1/2, or 1. Now it's your turn to compare these fractions, and I want you to try to do it without a number line. So you want to consider how the fractions relate to 0, 1/2, or 1. You should be able to explain this verbally or with sentences. So I want you to think about comparing these fractions as they relate to our benchmark fractions. How would you prove which one is bigger and relate each fraction to 0, 1/2, or 1? I'd like you to pause the video and press play when you think you know which one is bigger and why. Okay, let's see if our reasoning matches. So let me start with 5/8. I can think of 5/8, and when I'm thinking of the benchmark 1/2 and dealing with 5/8, I might want to think of 1/2 instead as 4/8. When something has the same units, it's really easy to compare. So I can see that 5/8 is just 1/8 bigger than 4/8. Okay? And then when I think about 4/5, I want to think about it as 1 whole. So when I'm talking about 4/5, I might want to think of 1 whole as 5/5. So 4/5 is just 1/5 smaller than 1 whole. So from this reasoning here, using what I know about my benchmarks, 4/8 is 1/2 and 5/5 is 1 whole, I can reason that 4/5 is greater than 5/8 because 4/5 is only a fifth away from 1 whole. Well, 5/8 is just 1/8 bigger than a half. So if I had drawn a number line, and I'm going to add that right now just to clarify my thinking, and I have 0, and I have 1. I want to put my benchmark 1/2 on there. I can label 1/2 as 4/8, and that helps me see that 5/8 is really going to be right about here. And then if I want to take a look at 4/5, I know that 1 whole is 5/5, so that's really just a fifth away from 1 whole. So in my reasoning and thinking about benchmarks, I'm thinking how close 5/8 is to 1/2. 5/8 is just 1/8 bigger than 1/2. And then I can reason 4/5 is only 1/5 away from 1 whole. So 4/5 must be greater. All right, let's take a look at our next two fractions, 2/5 and 6/10. We want to compare these thinking about our benchmarks, 0, 1/2, or 1. So this one, right away, it jumps out to me that 5/10 is equivalent to 1/2. So that tells me that 6/10 right here is just a little bit bigger than 5/10 or 1/2. So I can know that 6/10 would land a little bit past 1/2 on a number line. And then when I start to think about my 2/5, I know that 2/5 is just a little bit smaller than 1/2 on my number line. Okay, let me see if I can explain how I know that 2/5 is less than 1/2. Let's look at this picture here of different fractions with 1/2. So we can see 1/2. We can see that's the same as 2/4, which is the same as 3/6, which is the same as 4/8. If we take a look at the number of pieces, this circle has 2 pieces. This circle has 4 pieces. This circle has 6 pieces. This circle has 8 pieces. They're all an even number of pieces. If you have an even denominator or an even number of pieces, it's really easy to make 1/2. Where it gets tricky is when we have an odd number of units. So for example, when we have 5 units, it gets a little tougher to show what 1/2 is or to think about it. So let's quickly draw. I'm not going to do a circle because that's a little bit tough to model fifths on, but I can do my model here. 1, 2, 3, 4, 5. So I have 5 pieces. And let's say that I want to share half. Let's say that this is a candy bar. And I have 5 pieces that it can be broken up into. And let's say I want to keep half for myself and share half with my friend. Well, if I start shading and I want to keep half for myself and I want to give my other friend half, we would each get 2 full pieces. And then what would I do with that extra piece in the middle? I don't have an even number of pieces to divide in half. So I can think of it as we would each get 2, and I can cut this in half again. We would each get 2.5 pieces. So we would get 2 full fifths and then a half of a fifth. 2 full fifths and a half of a fifth. So although this isn't really a proper way to write a fraction, we can think about half of a fifth is 2.5 out of 5. Because when we have units of 5 or any odd number, we're not able to split these evenly in half. So whenever we have an odd number, we have to think about it a little bit differently, and we have to know whatever's right in the middle of it. So 2.5 is half of 5. One group of 2.5, another group of 2.5. So that's why when I see 2/5, I know it's just a little bit less than 1/2. 2/5 is less than 1/2, and then 3/5 is more than 1/2. So we can't get that exact equivalent fraction like we can for even number units. I hope that makes sense to you. So when I reasoned this through, I knew that 6/10 is just a little bit bigger than 1/2. What this model hopefully showed you without confusing you too much is that 2/5 is a little bit less than half. So if I want to compare these without drawing a number line or without necessarily drawing a model and just reasoning it out about fractions, I know that 2/5 is less than 1/2, while 6/10 is more than 1/2. So that means that 6/10 must be the bigger unit. Okay, here's the last problem that we're going to do. Compare fractions using benchmarks of 0, 1/2, or 1. I'd like you to try and reason this out and compare 33 hundredths to 0, 1/2, or 1, and 2/3 to 0, 1/2, or 1, and try to figure out which one is greater than or less than, or are they possibly equal. When you think you know what it is and could explain it with words or drawings or number sentences, press play again and see if our thinking matches up. Okay, so when I think about these two fractions, when I think about 33 out of 100 pieces, I kind of want to figure out what is half of 100. So if I had 100 units or 100 pieces, what would half of those be? That would be 50. So 50 hundredths is the same as 1/2. And I could set up my multiplication sentence, and when I multiply 2 by 50, I get 100. When I multiply 1 by 50, I get 50. So 33 hundredths, I know, is less than 1/2. And then when I think of 2/3, and again, this is a third, so it's an odd number of units, so I can't find that perfect half, but I can realize that it is larger than 1/2. And I can also think of it as how close it is to 1 whole, or 3/3. 2/3 is just 1/3 away from 1 whole, while 33 hundredths is less than 1/2. So from that, I am able to identify that 33 hundredths is less than 2/3, because 33 hundredths is less than 1/2, and 2/3 is greater than 1/2, as it's almost 1 whole. Okay, it's your turn for some independent practice. I'd like you to grab your problem set book and work on the lesson 12 pages. Rewatch this video or even parts of it if you need help. I want you to work hard, try your best. If you find yourself stuck and in need of help, please ask a friend that you think would be able to help you. I want to urge you to make sure that anything you guys talk about is math related, that you stay on topic and help each other really understand this lesson. Finally, write down any questions you still have about this lesson. You can ask me your questions later.